food restaurant estimates that the mean sodium content in one of its breakfast sandwiches is no more than 920 milligrams. So when they're saying that the mean content, that tells us mu. No more than tells us less than or equal to, what did it say, 920 milligrams. It's a good thing to know what kind of sodium contents in sandwiches and stuff like that. Yeah, especially when you get to be my age. Sample of 44 breakfast sandwiches. So what's that tell us? What equals 44? N. N is 44. Has a mean of 925. So instead of mu, what's this mean going to be? X bar. So X bar is 925. A standard deviation of 18. How do I represent standard deviation? How come S?
That's for standard deviation.
That's true, but how come S and not turbo? Sample, all right, because it's sample. Make sure you remember all that stuff. And alpha, that's our level of significance, is 0.10 or 10%. So we want to be 10% level of significance. Do we have enough evidence to reject the restaurant's claim? On this, you're going to do all that same stuff. First thing we're going to do the HO, HA. Let me give myself room here to do all this. What's our HO going to be this time? Remember, with the HO, what has to be in the HO? It's some equal to part, right? Less than or equal to, greater than or equal to, or just equal to. Well, if this is their claim, we just, that's it. So we stick that in there, 920. And since we're trying to disprove their claim, we're trying to say, is there enough evidence to reject their claim? That's where we want it. If we were trying to support their claim, we'd like it to be in the HA. All right, so, and I'm going to write claim out here. Make sure you're writing claim out there with which one is the claim each time, because that helps you to make your final statement. What's HA, the alternative hypothesis, going to be then?
Mu is less than, or, I don't know.
More than
Or, yeah.
920, greater than 920. Once we have that, what did it tell us to do next? I think we had a list last time. We found the mu, or the alternative and the null hypothesis. What did it tell us to do next?
You gotta find the Z, don't you?
Okay, next thing is to do this, but we already have that, right? Fine. Decide what alpha is. Alpha is 0.10. Then we gotta find our critical value, right? How do we find our critical value? Everybody remembers? So when we go to do this stuff today, they even tell you right above, up in the directions for 35 through 42, they tell you the steps. First thing, write the claim, the HO and the HA, we did that.
It'd be X bar minus mu. Determine the standardized. Draw the graph.
Okay, so we need to draw the graph, right?
Like he's trying to find it.
We are. We will here in a second, because that's all part of B.
Oh.
All right, so we draw the graph, and we're going to figure out if it's less than or equal to, is this left-tailed, right-tailed, or two-tailed? this might be something, remind me, Dane, we'll write this down, or you might write it down in your notes right now. You got less than or equal to, which way is it?
That'd be right.
It's right-tailed. That's right-tailed. If it's greater than or equal to, it's left-tailed. And if it's equal to, it's
Two-tailed.
supposed to be an equal, it's two-tailed. Might write that down somewhere to help you remember it. It's sort of backwards. If it's pointing to the left, then it's right-tailed. So that means this is over here. This is the good stuff where the claim is true. This is where we're going to reject the claim. That's our rejection region,
And it says calculate the test statistic.
which is our Z, right? And that's what you guys started to tell me. How do you find the Z?
X bar minus mu divided by standard deviation.
Slow down so we can do it. X bar, have your calculators out to help me. 925 minus 920 divided by what?
Standard deviation.
18 divided by
That's 344.
44. Anybody figure that out for me? Now you know what, we're figuring out the wrong thing. This is our test statistic. We actually use the chart to find the other. So we gotta find our Z-score by, if it's left-tailed and the alpha, this is the second part. That's what we need after this, so go ahead and figure that out. This is our test statistic here. This is what we're gonna see where it falls at. We gotta find it by using this chart. We know that we are, did we say left-tailed or right-tailed? Right-tailed. So for right-tailed, we want 10%. So we find on the chart where we're at 0.10, but we actually got to do 1 minus that. What's 1 minus 0.10? 0.9. So we want an area of 0.9. So you look on the chart and you find what's closest to 0.9000. Remember, you're on your standard normal chart this time. Are you on the positive or negative side?
So what do you go down to?
You don't know. You're looking in this area. We're using the chart backwards. You're looking for 0.900 as your area,
Oh, okay.
and then you find the number. See if I see anything close to 0.9000. Is it going to be exact?
Maybe not.
No. So just get whatever's the closest.
Closest is 0.9015.
I think there's something closer than that.
I don't see, I think I got the wrong chart.
You on the standard normal chart? We're going to use the t-distribution later, Jesse.
Oh, I
not
thought
right
you said
now.
to look at the T chart.
No, so look at the standard.
You must have said that earlier.
1.28. Does everybody see that? It comes out 0.8997, right? That's pretty close to 0.90. So what's our Z-score right here?
That would be,
Positive 1.28, right? Now let's find, this is our, so you gotta find the Z-score that goes on the graph. Then you got to find the Z-score that fits your information.
I did that. Do you want it?
Yep.
Want me to round it up?
Yeah, just tell me.
Alright, it's a 0.0419.
Well, sounds right.
Oh my God. I did it. That's what
Don't sound right. Anybody get something different? 1.84, that sounds better.
Did you type it all in?
You can.
I did. I did that.
So,
Okay, 925 subtract 920 equals divided by 18.
okay, so on top, what I usually do, on top, sometimes you can do this in your head, right? What's 925 minus 920? 5. Alright? So I just usually punch in, if I can figure that out in my head, I punch in 5 divided by, and then you gotta make sure you're dividing this. So you gotta really use parentheses and be careful with your parentheses. On my old calculator, I'm gonna have to use 2 sets of parentheses. On the new calculators, it doesn't use parentheses for the radicals, so you don't have to worry about it on there. But on this one, I'm gonna have to punch in divided by parenthesis 18, because I want it to divide by that whole thing. 18, then divided by again, second square root 44, parenthesis to close the parenthesis for the square root, and then close the other parenthesis for the whole bottom. So do you have the old calculator or new one? So you don't need these parentheses, but you do need the big parentheses that I have here. Because otherwise what it's gonna do, it's gonna divide by the 18, and then it'll take that number and divide by the radical 44, instead of,
Well, I thought we were supposed to do, because in the order it's shown, it's 5 divided by 18, then you divide it by that.
nah,
That's what it's shown.
you find, no, because this is a big fraction. So
Yeah.
you do all this, and then you divide 5 by that. We hit enter, and it looks like I get 1.842569, so on, so on, so on. Then the next thing we do, once we have our test statistic, once we have that, we look at our graph over here, and we decide where it falls at. Where does that fall? Does it fall in the white area or in the red area? In the red area, it falls right here. So what's that tell us to do with the null? Reject it. So right here, we're gonna, next thing we're gonna say is we reject the null. And then we got to pull all this together and make a statement about their claim. So what can we, if we reject the null, remember on the chart, on that little chart that tells you the 4 things that you write, that Grant loves so much because it says things backwards in crazy ways. So on that chart, I can't find it. If
Enough
we,
evidence to reject claim, false.
yeah, I don't know what that means.
That's what I had written down from here.
So today when we write it down, you might wanna write down the chart completely.
That's what I did. I have it
Yeah,
word
that
for
sounds
word.
like what I wrote on my PowerPoint.
Come in and look.
I'm not saying you don't have it in your notes. I'm saying that I didn't write it on the PowerPoint that way because that didn't make sense. So our HO, the HO this time was the claim. So we look at that first column and we're rejecting it. So there it says there is enough evidence to reject the claim.
What did I say?
You said something
I
completely
said
different than
enough
that.
evidence to reject claim, and then in parentheses it says false.
All right. That's not the way you read it the first time.
Is it?
All right, Jesse, I apologize, you were right. So, we're gonna reject the claim, so we can say, use our alpha with 10% confidence, or level of confidence, I should have said confidence level. We can decide there is enough evidence on the test. When we take a test over this after break, you're gonna have to write this stuff out. There is enough evidence, hopefully you write better than I do, to reject restaurants claim that sandwiches have less than 920 milligrams of sodium. And this is the kind of thing that with like McDonald's here in the past few years, you've heard a lot. And maybe you haven't heard it, but if you watch any of the news and stuff, McDonald's had to like redo their Happy Meals or whatever they are, because stuff like too much sodium, too much trans fat, too much, so they had to redo them, and they start putting, instead of French fries, they start putting what in them? Apples. Because there was too much of this stuff in them, too much sodium and stuff, and people were throwing a fit about it. So this is the kind of stuff they look at. Now here lately, it's been the fact that their quarter pounder probably isn't a quarter pounder anymore, because the patties have gotten smaller. So we went out and took 50 McDonald's quarter pounders, and we could weigh the patties and decide, okay, is this actually a quarter pound of meat or not? Other questions? Too hard for you?
Not the math.
No. People.
Go to Starbucks and dumping it out, like take all the ice out.
If they go there, why do they complain about it? Like, they know McDonald's is fat, so what they expect?
I don't know.
No fries.
You'd have to, when you ask that question to me, what do they expect? How am I supposed to know what they expect?
Well, you use we go and take the patties.
Well, if we were
Feel
gonna,
like
if we were gonna do a sample, and if we were gonna try this,
Sean takes that to heart.
he what?
He's the McDonald's.
He's general manager.
He's the manager.
He's the
He's got the west side covered.
He's just in the
It's just McDonald's.
He owns the corporation.
Other questions?
You own that, or with chain, you own that one?
Ask now.
Maybe Gucci's still in those.
Which one? 47. 47. Let's try and make this one go a little quicker. Maybe we'll use the calculator on this one. Instead of, this is the long way. Could we use the calculator to do like the P and use the alpha and compare those two? Yeah. So sometimes, again, we talked about this last time. Sometimes we're going to use this method where we actually draw the graph and we see if it falls in the rejection region. Other times we can compare P to alpha and decide less than, greater than, whether to reject or fail to reject. This time we'll use P and alpha to make this one go a little quicker. 47. Let's see. You believe the mean annual water usage of U.S. households is less than 127,400 gallons. So it's less than 127,400 mean usage. That's what we believe. You find a random sample of 30 households, so that's our N again. N equals 30. Have your calculators out. We are going to use calculators on some of the stuff today too, so it'll be a different test, and you got to be able to keep the kinds of tests straight. And you find the mean usage is 125,270. So our sample mean 125,270 gallons. With a standard deviation of 6,275. 6,275. You conduct a statistical experiment where HO, so this time they're telling us the HO. HO is to 127,400. And HA is mu is less than 127,400. Which one of those two is our claim? HA. And that's where we want it if we're trying to prove that it's correct. If we're trying to prove that our claim is correct, we want it in the alternative hypothesis instead of the null hypothesis. And our alpha this time is 0.01. So with 1% level significance, explain why you cannot reject the HO. Alright, so let's, we'll just find P, which is our area, which is, we could find on the chart. We're not going to this time. And we already know alpha is 0.01, or 0.01. To find P, we go on the calculator, go to stat, test. We want the z-test this time. Hit enter. We're not putting in data. If you look at some of the other problems where they had the list, that if we put those in the list, then we would be doing that. This time we're just using stats, and we're going to put in all of this information. Our mu this time is 127,400. Our standard deviation is 6275. Our X bar is 125,270. And our N is 30. And then you get to the line where it asks you, is mu, is the, what you're looking at is the HA less than, greater than, or not equal to. Alright? And this time we got the HA is less than. So on that line, you're always looking at the HA to decide which one. And ours is less than, so I go to over to less than, hit enter, then I go to calculate. And it should tell you a P. What's our P score? .031, something like that. And all we're going to do is compare those two. We got .031 and .01. Is that less than, greater than, or equal to? It's greater than. And we said last time, and every time I'm doing these kind of problems, first thing I write on my paper, P is less than, we do what? Reject. If P is greater than, we fail to reject. So P less than, reject. P greater than, fail to reject. So this time, can we reject it or fail to reject it? Fail to reject it. So we fail to reject that claim right there. Now, let's see what explain. It says we cannot reject HO. Oh, yeah, because we fail to reject it. All right, so we fail to reject that, so we can't say for sure that with a 1% level significance that it's going to work out that way. Now, if we would have used, instead of a 1%, what if we would have used a 5%? Then we could have rejected the claim. And that would have said then, hey, we're right. But when we use just a 1%, because we were making it so that our percentage out here is smaller than it could fall in, we don't have enough evidence to reject that claim. And again, could we have done this out the long way? Yeah, I think maybe. I'm trying to think if when I did it, no, I used the calculator. Other questions? Sean, you can do all that? Lying to me? All right. Right? This is what we're going to do today. Hypothesis testing with small samples. Just write down this title here. Hypothesis testing for the mean with small samples. We're going to find critical values using the t-distribution. That's why I told you to try to find that t-chart. Did everybody find their t-chart? Yes, no, if you didn't find it, let me know, because I got a few of them up here. Didn't find one, don't.
What do you mean
The t-chart. The thing that Jesse was looking at a little while ago that,
Oh, the t-distribution?
yeah. Yeah, not like tea you drink. Use the t-test to test the mean. Use technology. I think today, because I'm not feeling real well, we're going to use technology a lot. We're going to use a calculator because I don't feel like working stuff out longhand. It's not going to help Jacob out, but you're just going to have to live with it. I'm just kidding. It probably will work a couple of them out longhand. Kills me because I work them out longhand, and on the test, what do you guys do? You don't work it out longhand. Don't even lie.
I'd rather not use the calculator.
Do what?
I'd rather not use the calculator.
So again, just this. You don't have to write all this if you've already started writing it. You just wrote more than you had to. Finding the critical values. These are going to be our steps. This is what we're going to do to find critical values. Number one, identify the level of significance. Can everybody tell that that's an alpha? Alpha. Identify the degrees of freedom. Does anybody remember how to find the degrees of freedom? N-1. And then you're going to find your TO. Your TO is your critical value. So you're going to find that. If it's left-tailed, we're going to use it. We're going to use the chart. All this is going to come from the chart. If it's left-tailed, use one-tail alpha. If it's right-tailed, use one-tail alpha. So these two are the same thing. A and B are the same on the chart. If it's two-tailed, then it says two tails, and you use the alpha. I'll give you a second to write that down. Then we'll do a couple of examples to show you how to do that. Not very difficult because it's all on the chart. Right, on this example, find the critical value for TO for the left-tailed test given alpha is 0.05 and N is 21. So you're going to grab your t-distribution chart, which I lost mine already. So grab your t-distribution chart, and what I did on the top of this T-chart, where you got these graphs, I wrote in this on the second one, the left-tailed, write in, make sure this is on the pin still, write in greater than or equal to. If you're left-tailed, you're going to be greater than or equal to. On the next one, less than or equal to. This is on the second one, not on the first one. And then equal to above the other one. So that way, maybe, we were talking about that a few minutes ago. That way, when you see less than or equal to, or greater than or equal to, you know that it's supposed to be a left tail. When you see greater or less than or equal to, it's supposed to be a right tail. When you see equal to, it's going to be two tail.
Is this the last time we're going to use this chart?
I mean, this whole chapter maybe.
Right in the middle. Just
Really
if
what?
if we use this for anything else other than that, I would be confused.
Oh.
I wrote it right in the middle.
Yeah, that's right. So find the critical value TO for the left-tailed test. Given alpha is 0.05, N is 21. First thing you gotta do is find your alpha. It's right there. All right, that's not too difficult. Then the other thing you gotta do is find your degrees of freedom. What's your degrees of freedom this time?
20.
20. Use those two numbers. Remember, when we used this before, we just used the level of confidence C, the top numbers at the top. Now we're using the one-tailed and the two-tailed. Okay, so now we're using those two rows right there. Do we want one tail or two tail this time? One tail. We're just left-tailed, so we want one tailed. We go down to DF is 20, and we go over to 0.05. Now you gotta be careful because you gotta make sure you're in that one tail row.
It's 1.725.
Does everybody agree with that? Now you gotta be careful. Said we're left-tailed. So we're over here somewhere.
That would be negative.
That can't be 1.725, can it? So what do you gotta do to that?
Negative.
If you're left-tailed, you gotta remember to make it negative. They give you all the positives here. So if it's left-tailed, you got to make sure that you put in the negative. See if we did it right. See if Dalton did it right, because I didn't even look at my chart. One tail with the alpha. Negative 1.725. Remember that 0.05 is your area there. That's your area. And the negative 1.725 is your actual T-score. That's your critical value. That's this line right here. So when we go to find something, if we figure out that our test statistic is T equals negative 1.528. Are we going to reject or fail to reject?
Fail to reject.
Because that's going to fall somewhere like right in here, right?
Yeah.
So we fail to reject. So it's the same kind of stuff, you're just using a T-chart. How come we're using a T-chart instead of the normal? We got small samples. We're less than 30. Let's try another one. You got 0.05.
This is 2
N is 26, so what's our DF? 25. This time we're two-tailed. So when we draw our little graph, it's going to look like this. So Sean's going to have to remember, how many answers is he going to have for this one?
2.060.
2. He's going to have one here and one there, right? So we look at 0.05,
Yeah.
two-tailed, and 25.
Is it 2.060? Negative and positive.
2.060.
Yep.
And we want the positive and the negative. So what's this critical value right here?
Negative.
Negative 2.06. What's this one?
Positive.
Positive 2.06. So you've got to be able to use that chart, find the critical values. Degrees of freedom we found were 25. We looked at, used the chart to find all this stuff. Negative 2.06 and 2.06. Again, this is your area. 0.025 is the area in this tail. 0.025 is the area in that tail. So what if we figured out that our T-score, our test statistic was 2.1. Do we reject or fail to reject the null?
Fail to reject. No, reject.
We reject, don't we? Because it falls just right in here somewhere.
Yeah.
So we would reject the null, same as what we were doing. On this, probably the only things I would write down on this, all this other stuff you know, we've already talked about N being less than 30. The test statistic, what we're testing is probably gonna be, X bar, cause we're dealing with means, so we're using that sample. You might write this down, how to find T, that'd be a good thing. Is there really a whole lot of difference in finding T and finding Z? Same thing, the only difference is instead of sigma here, they put in S, which most of the time we put S in there anyway because we don't know sigma. And hopefully the degrees of freedom, you remember what the degrees of freedom are. Your standardized test statistic now, instead of being Z, is gonna be a T. Dalton, you might wanna help Jesse every now and then put the pencil in his hand. So I just can't take it, I can't not be a smart aleck when Jesse's sitting there not writing and he's the one that we're always waiting on to write stuff down.
Well, I had to listen for a minute so I could learn. I can't write. I already have this written down. Yeah, I do.
Explain to him why that, Dalton.
Because the S and the, yeah, I already got it.
Now you did. You did when you said it. Now he's gonna look back and explain to him what's different, Dalton.
I know, I have it next to it.
There you go. Not one day, I tell you, I feel poorly today. Not one day could you not just be a studious young man. On this stuff, this is gonna be our steps to doing this. I highly suggest you write down these steps. Now, I wouldn't write down all of this. This is ridiculous. That's why I put this stuff out here. First thing, step one, what's the first thing you're gonna do to do one of these problems? State your null and alternative. Right, Sean? State the null and the alternative. Next, find the alpha. Identify the alpha. Is it usually very hard to, I don't even know why we put this in there as a step. Is it very hard to find the alpha? No, they tell it to you. Third thing, find DF, the degrees of freedom. When I made this up, I must have thought that Nick was an idiot because I really broke this down, didn't I? That's probably a little too much as far as the steps go. Fourth thing, here's where it actually starts getting difficult. We got to use the chart. Use the chart to find the critical values. So critical values, value or values, one or the other. We're going to use the chart, and it's the T chart. Dalton now knows that the T chart doesn't have like green tea and it's not that kind of T chart. He goes to one of his hippie hangouts where they read books and drink Kai tea or whatever it is.
I love reading books.
So we do all that stuff, that's pretty easy. Use the chart, we just got done doing that to find the critical values. Probably, you might want to, every time you find the critical values, you might want to draw your graph, put in your critical values. If it's left-tailed, you want just there. If it's right-tailed, you want just there. If it's two-tailed, you want both of them. Draw the graph. That helps you to picture it sometimes. Every problem I do, I draw the graph because I can't do it without picturing it. I know Jacob M over there, he doesn't have to draw the graph, it just sticks in his brain. The next thing, determine the rejection regions. So just determine the rejection regions, that's step 5. Region or regions, and that's what we were talking about with the graph. Number 6, find your test statistic. We're going to find the test statistic by using that formula. And again, that formula is written terrible that way. I hate the slash there, I should have changed that. This on bottom is S over the square root of n. That's what's on bottom there. But Jesse just wrote that down, so probably really doesn't need me to explain it to him. After you find your test statistic, so we got this, we went to the chart, we found our critical value, that's our t sub 0, then we find our t, and all we do is decide, does t fall in here, or does t fall in here? And that's going to tell us whether to reject or fail to reject the null. On this, you can write it all down. It's not like it's that long or anything, but I would, if I was writing the notes, I'd probably just write reject or fail to reject null. Make that decision. What's the last step? After you reject or fail to reject the null, what do we do? You interpret it. Alright? See that? Just popped up as soon as Riley said it. I didn't have to hit it. That's the word. So you interpret the decision. And when you interpret the decision, you're going to use what? That 4-box chart, which is on the next slide. So if you don't remember the 4-box chart, we'll pull it up here in a second. You can write it down again. Remember, when you're interpreting it, don't just say, there is not enough evidence to support the claim. Tell me what the claim is for that certain problem. If it's just a generic problem, then you can say there's not enough evidence to support it. But you got to be able to explain it out. It's like writing an English paper. You can't just say, yeah, I don't support that. Well, if you're either supposed to support it or not support it, you better tell what you're supporting or not supporting in your English paper, right? Same idea here. That's the box. Remember, if your claim is in the HO spot, then it's one of these two things. If your claim is in the HA spot, then you're going to use one of those two. Again, which one, if we're trying to support the claim, where do we want it? Which one do we want it in? The HA. So if we're trying to support it, I'll be out of the way in 1 second. If we're trying to support it, we want to be in there. If we're trying to disprove the claim, we want the claim to be in the HO. So if we're trying to support it, put it in the HA. If we're trying to disprove it, put it in the HO. Because the only thing we can do if the claim is in the HO is reject the claim or say, there's not enough evidence to reject it, but we still don't believe it. 1 week, Nick. I might just take tomorrow. Feeling the sickness. Handle all this, Jesse. Easy stuff.
I guess.
All right, let's do this example. The used car dealer says the mean price of a 2005 Honda Pilot LX is at least $23,900. So you walk into some place and I'm trying to sell Carson a car, this Honda Pilot LX,
Sounds like.
and I'm going, yeah, Carson, you ain't gonna find this car for less than $23,000 or $23,900 anywhere. It just doesn't happen.
Well, if you're a car salesman, then I'm actually seeing you wrong.
Okay. So, and that's what we're trying to prove here. You suspect this claim is incorrect and find that you go out and you find a random sample of 14 similar vehicles that have a mean price of $23,000 and a standard deviation of $1,113. Is there enough evidence to call that dealer a liar? Well, that's what we're going to figure out. All right, so if we go back through those steps, first thing we're going to do is write the HO and the HA.
Have leather seats.
Let me do this. See, that's why. Got it, not say. So let's see. Their claim, they're making a claim. Mu is at least, so greater than or equal to $23,900. That's their claim. We're going to write the HO. Is that going to fit in our HO? Yeah, because it's got the equal to part with it. So mu is greater than or equal to $23,900. Put the claim, write the word claim next to that. Our HA then is going to be, wrong way, mu is less than $23,900. Next thing we do is find alpha. I think that's the second thing they said to do, right? On the steps there. Alpha this time is 0.05. Then the next thing we do is find the DF. Well, first we probably should have wrote N up here somewhere. What was N this time? 14. So what's our DF going to be? 13. Then we use the chart. So grab your T chart. We got to decide as we use this T-chart, is it one-tailed, two-tailed, and is it left-tailed or right-tailed? If it's one-tailed. Well, we look right here, and that's what we wrote up above here. Which one is that, left-tailed, right-tailed, or two-tailed? Left-tailed. So I always write that down somewhere, left-tailed. So we know that it's going to look something like this. We're going to have a critical value right here, and this is the stuff that we're looking at where we're going to reject their claim. For alpha at 0.05 and DF at 13, and we are one-tailed because we're left-tailed. What's our?
1.771.
That's our T sub 0, right? 1.771. Now that doesn't fit. So what do we do? You make it a negative. So it's a negative 1.771. That's our critical value. That's our critical value right there. Negative 1.771. What's the next thing they told us to do after we found the critical value on those steps?
Determine the rejection.
We did that, right? That's right here.
Oh, fail to reject.
Before we need something before that.
Okay, T equals.
We gotta find T, right? So we gotta use that formula. What goes on top?
X bar minus
Do we know X bar? Yeah, we do. We just didn't write it down. Probably ought to write it down up here. What is X bar? 23,000. And we also need our S, which was what? So X bar, 23,000 minus mu, which is 23,900 over S, which is 1,113 divided by square root of N, which is 14. Might help me out, do that on the calculator. Remember, we probably, you wanna do the subtraction, then you're gonna hit divided by, and you wanna divide by that whole setup there. Anybody get an answer? Y'all too chicken to say it. Riley's not scared. Anybody else get that? So we look at that negative 3.03. Now we decide to reject or fail to reject. Where does that fall at? Does it fall in here, or does it fall in the black part? Falls in the black part, doesn't it? So it falls right in here somewhere, way out here somewhere. So what's that tell us to do with this claim? We reject it. So we reject the HO. We reject the HO. I'm not gonna write it all out this time. Somebody explain to me, what's that mean if we're gonna reject the HO using that chart? The HO was the claim, right? So if we reject the HO, what's that box say, the very first box on that chart?
There is enough evidence to reject.
There's enough evidence to reject the claim that what was true?
It was
The mean,
price of that car is no smaller than 20.
right, that the mean value is $23,900 or more. So we can say that that car dealer was not telling us the truth. See if we did all this right. Negative 1.771, that was our critical value. We found our test statistic, got that by using the T formula there. The decision was to reject the HO at a level of significance. We can say that there's enough evidence to reject the claim that the mean price is $23,900. What's different when you're doing a two-tailed? I know I'm skipping over this one. You just have to make sure on the chart, use the two-tailed row. Don't make a mistake there. Remember with two-tailed, it's gonna be the equal to or the not equal to. On the calculator, might wanna write this down. On the calculator, if you're gonna put this into a calculator, and we'll do one using the calculator, you're gonna hit stat, test, t-test. We want stats if we're putting in mu and all that stuff. Data if we're putting in a sample list. So if we're putting something in the list, you're still gonna have to do all this, the first stuff here. Write the HO and the HA. Have your calculator out, and we'll do a problem with the calculator right after this so you can see how to do it. My list again is not very good. I'm not sure why. Last couple of PowerPoints I sort of slacked on. Slacked on the how to do it on the calculator. what's different on this one? What's different on what we're doing here from the last one?
We're using
T-test instead of Z-test. I can't remember if the T-test is the same spot on all the calculators or not. We'll find out here in a minute, I guess.
Number 2.
Oh, got a new calculator. I'll use my old calculator then. So let me see. So if we're doing this, the American Automobile Association claims that the mean daily meal costs for a family traveling, so on, and all that. You take a sample of 11 and find the cost to be 141, standard deviation 20, your alpha is 10% or 0.10. Assume the population is normally distributed. Are we going to accept what the American Automobile Association claims or not? First thing you're going to do on this, you still got to write your HO and your HA. So our HO this time, it says American Automobile Association claims that the mean daily cost for a family of 4 traveling on vacation in Florida is 132. So the mean equals $132. What's our HA going to be then? Mu does not equal $132. This time we know our N is 11, our X bar is 141, our S is 20, and our alpha is 0.10. Now let's look on here and see what we need to do the t-test. So you hit stat, test, go down to 2. You said yours was 2, Dalton?
Yep.
So that's what it is on mine. Do we have enough do we have everything that they want? Yeah. Remember, to find that last line, you're looking right here at whatever HA is. So you're going to look at what HA is, and that's what we're going to put in on the last line. This time we're using stats. Our mu is 132. Our X bar is 141. Our S is 20. Our N is 11. And we look right here and we want the not equal to one. So go to not equal to, hit enter, and then we hit calculate. Now what are we going to use off of that screen?
Draw.
So don't hit draw.
I did. It's pretty cool.
Yeah, we don't want to draw this time. What do we use off of that screen? Use a P, right? So what do they tell us, or what's it come up P is? So that's our P. What are we going to compare that P to? We just did this on the last assignment. Compare it to what? Compare it to alpha. So we're going to compare P to alpha. Is P greater than alpha or less than alpha?
Less than.
Less than alpha?
Yep.
Does everybody agree with that?
No, it's the other way.
That was less than.
I know, but you said it's P
I said it's P.
less than alpha. I said, yes, P is less than alpha. I mean, greater than, my bad. Sorry.
So P is greater than alpha. Again, I always write it on the top of my paper as soon as I start one of these assignments. P is less than alpha, what do we do? Reject the HO. If P is greater than alpha, then we fail to reject. So this time, which one? We fail to reject the alpha. We fail to reject, or not the alpha, the null. Fail to reject the null. So what are we going to say about the AAA claim there? American Automobile Association.
That they,
If we fail to reject the null, what are we saying about their claim? It's probably true, right? Now, are we gonna give them credit for it being true? No, we're gonna say, with a 10% level of significance, there is not enough evidence to reject the claim that the average cost is $132. See if we did all that right. Do the HOHA, we did that. Calculator, we did that. Got 1.66 as our test, or as our P.
wow,
We're there. That's what yours look like. Our decision, we got that, it's greater than 0.10. Fail to reject, it's not enough evidence to reject the claim that the mean daily cost is 132. Again, why do we say it that way? Because we're not giving them credit for being correct. But we're saying, you know what, we can't say that they're incorrect. All right, that's your assignment. I'll tell you what, we got 7 minutes. We'll start working some of them together. We were supposed to have more time than this, but since I'm moving slow today, we'll start working some of them together. The more we get done, the better off for you. The more we get done, I'll probably take some problems off of that. So get out a sheet of paper, your book. So everybody got that written down? I don't know if I got another slide or not. Number 3. Find the critical values for the indicated t-test, level significance, and sample size n. So they're saying a right-tailed alpha is 0.05 and n is 23. So we know alpha is 0.05. N is 23. Well, if n is 23, what's df? 22. We want to find the critical values. This one is, they told us it's left-tailed. So all we're going to do is look on the chart. One-tailed, 22, and we go over to 0.05. What's it say it is?
1.717.
Now, it's left-tailed, so what do we got to remember?
Negative.
Negative. That's number 3. Number 4, that chart out, so I don't have to write all this down. Number 4, right-tailed, 0.01, and n equals 11. So what's our DF going to be? 10, so we go down to 10. We're right-tailed, so we're one-tailed, and we want 0.01. What's that tell us?
that gives us 2.764.
That sounds right. Is it? Right-tailed, so we're one-tailed on 0.01. Yeah, that would be right. I'm looking at the wrong thing. 0.01. 2.764. Is it positive or negative?
Positive.
Positive. That's our answer. Number 5. Sorry, I was looking at 0.10. Number 5, left-tailed, supposed to be right-tailed, wasn't it?
3, 4.
Oh, no, we did right. Left-tailed. I think we did the first one wrong. We did do the first one wrong. I wrote it down wrong. This is supposed to be right-tailed, so what's that gonna change? Positive, sorry. I was reading number 5. This one's left-tailed, 0.10, n equals 20, so our DF is 19. 19, go over or down to 19 and go over to 0.10, one tail. What do you come up with?
1.328. It's negative.
It's a negative. So that's our answer on that one, negative 1.328. Number 6, left-tailed, again, 0.01 and 28, so 27, one-tailed, 0.01. What's that give us?
2.473.
Everybody agree with that?
Yep.
It's close. Negative. Tell you what we'll do here, since we got spring break. We got those 6. We got 3 through 6. We got 4 of them. Do what? 6 more? No.
Okay, 5.
Let's do 7 through 37. The odd. Darcy's mad at me now because he just did number 8. I'm sorry, Darcy.
Tried to work ahead.
Just change number 8 to number 7.
Have a good break. Yeah, don't forget about Prop stats get done today, so it's out of the way.